Hello everyone, myself Tanvi Patel, working as Assistant Professor in Computer Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Subject is IoT and its application, and Unit 1 was Introduction to Internet of Things. So today our contents are Enabling Technologies, IoT Challenges and IoT Levels. So first is Enabling Technologies. IoT is enabled by several technologies including wireless sensor networks, cloud computing, big data analytics, embedded system, security protocol and architectures, communication protocol, web services, mobile internet and semantic search engines. So these are the type of enabling technologies in IoT. So first one is wireless sensor networks. A wireless sensor network comprises of distributed devices with sensors which are used to monitor the environmental and physical conditions. A wireless sensor network consists of a number of end nodes and routers and a coordinator. End nodes have several sensors attached to them in node and also act as a router. Routers are responsible for routing the data packets from end nodes to the coordinator. The coordinator collects the data from all the nodes. Here in figure you can see how the wireless sensor network works. So, coordinator also act as a gateway that connects the wireless sensor network to the internet. Some examples of wireless sensor network used in IoT system are described as follows. Weather monitoring system use wireless sensor networks in which the nodes collect temperature, humidity and other data which is aggregated and analyzed. Indoor air quality monitor system uses wireless sensor networks to collect data on the indoor air quality and contraction of various gases. Moisture monitoring system uses wireless sensor network to monitor soil moisture at various locations. Surveillance system uses wireless sensor network for collecting surveillance data such as motion detection of the data. Next is smart grid use wireless sensor network for monitoring the grid at various points. Last one, structural health monitoring system uses wireless sensor networks to monitor the health of structures, that is the building, bridges, etc. by collecting vibration data from sensor nodes deployed at various points in the structure. Now next is cloud computing. In cloud computing, it is a transformative computing paradigm that involves delivering applications and services over the internet. Cloud computing involves provisioning of computing, networking and storage resources on demand and providing these resources as metered service to the user in a pay as you go model. So, cloud computing resources can be provisioned on demand by the user without requiring interactions with the cloud service provider. The process of provisioning resources is automated. In cloud computing, resources can be accessed over the network using standard access mechanism that provide platform independent access through the use of heterogeneous client platform such as the workstations, laptops, tablets and smartphones. So, in cloud computing, services are offered to users in different forms, that is infrastructure as a service, platform as a service and software as a service. In infrastructure as a service, it provides user access to raw computing resources, such processing power, data storage capacity and networking in the context of a secure data center. Next is platform as a service in which it offering provides computing and storage infrastructure and as a development platform layer with components such as web servers, database management system, and software development kits for various programming languages. Last one is software as a service. Here it provides offer application layer services tailored to a wide variety of business needs such as customer relationship management, marketing automation, or business analytics. Now, next is big data analytics. In big data analytics, it is a process of collecting, organizing, and analyzing large set of data to discover patterns and other useful information. Big data analytics can help organization to better understand the information contained within the data and with also help identify the data that is most important to the business and future business decisions. So, in business data analytics, working with big data typically want the knowledge that comes from analyzing the data. Some examples of big data generated by IoT system are described as sensor data generated by IoT systems such as weather monitoring stations. Next, machine sensors data collected from sensors embedded in industry and energy system for monitoring their health and detecting failures. Last, health and fitness data generated by IoT device such as wearables, fitness band. Next, data generated by IoT system for location and tracking of vehicles. And last one is data generated by retail inventory monitoring system where the big data analytics being used. Now, in big data, it can be described by the following characteristics. So, four characteristics are volume, variety, velocity, and veracity. Now, next is communication protocol. In communication protocol, it acts as a backbone of IoT system and enable network connectivity and coupling to application. Communication protocols allow devices to exchange data over the network. Multiple protocol offers describe different aspects of a single communication. So, a group of protocols designed to work together are known as a protocol suite. When implemented in software, they are called as protocol stack. Internet communication protocol are published by the Internet Engineering Task Force. The IEEE handles wired as well as wireless networking and the ISO handles other types. The next one is embedded system. As its name suggests, embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system can be an independent system or it can be a part of a large system. So, in embedded system, it is a controller programmed and controlled by a real-time operating system with a dedicated function within a large mechanical or electrical system, often with real-time computing constraint. 98% of all microprocessors are manufactured to service as embedded system component. An embedded system has three components. It has hardware, it has application software, and it has real-time operating system. Now next is IoT challenges. So in IoT challenges, IoT deployment is diversifying from customer-based applications such as smart homes devices and wearables to mission-critical applications in the area of public safety, emergency response, industrial automation, autonomous vehicles, and the IoT medical things. The top 5 challenges of IoTs are connectivity, continuity, compliance, coexistence, and cybersecurity. So, the first one is connectivity. enabling a seamless flow of information to and from a device, infrastructure, cloud, and applications. It is a top IoT challenge because wireless connectivity is highly complex and dense device deployment further complete operations. Responding to connectivity challenges require design and test solutions that are higher flexibility and configurable and upgradable to meet future needs. Flexibility is needed to test devices with many radio formats to access devices' performance under actual operation modes and to support over the air testing in signaling mode without the need for a chipset specific drivers. Next is continuity, ensuring and extending battery life. One of the most important consideration for IoT device, a longer battery life is a huge competitive advantage in consumers IoT device. For industrial IoT device, a battery life of 5 or 10 years is the common expectation. For medical devices such as pacemakers, device life can mean the difference between health and the death. Next is compliance. IoT device must adhere to radio standards and global regulatory requirements. Compliance testing include radio standards, confirmations and career acceptance test and regulatory compliance test such as RF, EMC and SAR test. Compliance testing is complex and time consuming. It can take days or weeks to complete it if performed manually. Now, the next is coexistence. With billions of devices, congestion in the radio channel is a problem that will only get worse. To address wireless congestion, standard bodies have developed test methodologies to evaluate device operations in the presence of other signals. Coexistence testing is therefore crucial to measure and assess how a device will operate in a crowded, mixed signal environment and to assess the potential risk in maintaining wireless performance in the presence of unintended signals found in the same operating environment. And the last one is cybersecurity. Most traditional cybersecurity protection tools have focused on network and cloud. Endpoint and over the air vulnerabilities are frequently overlooked. While mature technologies like Bluetooth and wireless LAN are used in many applications, little has been done to address the OTA vulnerabilities. That is the weakness of the system. Now, the last topic is IoT levels. Here, the IoT architecture element vary based on application of use. Based on this fact, various levels are defined for IoT system. By taking an example of an air conditioner whose temperature has to be monitored to understand the IoT levels. So, the IoT first level is this level consists of air conditioner, temperature sensors, data collection and analysis and controlling and monitoring app. The data sensed is stored locally. The data analysis is done locally. Monitoring and control is done using mobile app or web application. The data generated in this level application is not huge. All the control action are performed through internet. For example, room temperature is monitored using temperature sensor and data is stored or analyzed locally. Based on analysis made, control action is triggered using mobile application or it can just help in status monitoring. IoT level 2. This level consists of air conditioning, temperature sensor, big data, that is bigger than the level 1, cloud and control and monitoring app. This level 2 is complex compared to level 1. Moreover, rate of sensing is faster compared to level 1. This level has voluminous size of data. Hence, cloud storage is used. Data analysis is carried out locally. Cloud is used for only storage purpose. Based on data analysis, control action is triggered using web app or mobile application. For example, agriculture application, room freshening solution based on odor sensors. IoT level 3. As shown in the figure above, this level consists of air conditioner, temperature sensor, big data collection, cloud and control and monitoring app. Data here is voluminous, that is big data. Frequency of data sensing is fast and collected sensed data is stored on cloud as it is a big. Data analysis is done on the cloud side and based on analysis, control action is triggered using mobile application or web application. For example, agriculture applications, room freshening solution based on odor sensor, etc. are the used. IoT level 4. This level consists of multiple sensors, data collection and analysis and control and monitoring app. At this level, multiple sensors are used which are independent of the others. The data collected using this sensor are uploaded to the cloud separately. The cloud storage is used in this level due to requirement of huge data storage. The data analysis is performed on the cloud and based on which control action is triggered either using web application or the mobile application. And the last one is IoT level 5. This level consists of multiple sensing, coordinator node, data collection and analysis and control and monitoring application. This level is similar to level 4 which also has huge data and hence they are sensed using multiple sensors at much faster rate and simultaneously. The data collection and data analysis is performed at the cloud level. Based on analysis, control action is performed using mobile app or web application. So this was the IoT levels. Thank you.